I will start here now with the red section. It means the softwares for structural design. Okay. So the first new feature I would like to share to you is related to CYPECAD. Okay, CYPECAD, that is our software to design reinforced concrete structures. For example, we can also design here steel structures or even wooden structures, since they are created in frames. Okay, so framed structures can be analyzed or designed with this software. It's maybe one of the most famous softwares that we have. It's also one of the we have the software for a long time ago. And one of the new features that we have here, actually we have a lot of them here, it's just in CYPECAD, but one that I think it's one of the most interesting, it's this new option that we have here, this little button, that is the option to introduce, analyze, and design ramps. Okay, we can create different types of ramps, size these ramps also, have all the details, the reports of these ramps, and it's now available since 2024A version here at CYPECAD. Okay, so this option, it's available here in the BIM definition, and to activate this option you must have different levels in your project. So when you are working in the column definition, you must create here using these options to add groups or add floors. Okay, you must have at least 2 floors to then start working with a ramp. Okay, if you just have 1 floor, it's impossible to have a ramp. Okay, so if you see this option blocked or in a gray color, it means that you don't have created your levels or your floors. Okay, so in this case, I already created different levels to this structure here. I'm working in the floor 1. Okay, and if I click here, I can see different options related to this new model. Okay, so this is actually a new model. It's not just a simple function or a simple feature. It's actually a whole model. So you must have the code to activate this model in your license if you are if you want to work with this new ramp system. So you must check with your sales contact to include this model in your CYPECAD to work with it. Okay, how it works? Actually, it's quite simple. We have here different options to create a new ramp core. You can edit a ramp core that was created before. You can delete a ramp core. You can also then move a ramp core that was previously introduced somewhere in our structure, rotate, and also you have the geometry and the position of this ramp. Then you can get the details, the steel details in this case, and also view the displacements, forces, and required areas, do shear using contour plots. Okay, we'll try to see everything in one example. I already created one ramp here, but I will create a new one just to show you how it works. Okay, so to create a new ramp, I'll click here, and we'll have this new windows here. Okay, let me close this one. Let's begin with the first option, that is add a reference to this ramp. For example, this is going to be my ramp. Let's add a name, my new ramp, for example. Okay, and here I have different ways to add ramps. The first option that I have is just add a simple ramp. Okay, to do that, I will define a width, so some geometry information, width, and the rotation of this ramp in case I have a curved ramp. It could be to the left or to the right. I can also define some lateral loads and live loads. Okay, but then actually what I need to do is to add different spans. The minimum is going to be 1 span, just a linear ramp, straight span, but I can also combine different spans and create a more complex ramp. Okay, so let's start creating that. So for example, this flight could be one flight or could be repeated, so I can have equal consecutive flights, a number of equal consecutive flights. For example, maybe I have 4 floors, 4 levels in my building, so maybe I can add here 4 times the same flight. They will be in the same position but in different flights. Okay. And here, when I create, I can create this the geometry of these flights. Okay. For example, I can create, as I said before, just one element. So one of these pieces of my flight that could be a straight flight or a curved flight. Okay. So this straight flight would be a length. Actually, it's the projection of this length on plan. Okay, so 5 meters would be this projection here. And then I can define the slope of this flight using 2 options. I could define here, for example, this slope in a percentage, for example, 20% here. If I define 20% here and it's 5 meters, so I will have a changing level of 1 meter. Okay, if I change it to 10%, I will have 0.5 meters. Okay, so we have this information here to help us to calculate the difference between levels once we introduce this data here. But we have also this option here that is introduce the height or the distance between levels that we want to cover with this this part of the ramp. So if I put here 2 meters, for example, I will have 2 meters. As I have 5 meters in length, my slope is going to be 40%. That is too much for sure. Okay. If we work with a curved option, we'll have some other options here, like how many degrees we want to have in this curve. For example, 45 degrees, or as it was before, 90 degrees. Also, we can define the inner radius here. Okay, 5 meters or 2 meters or 10 meters. Okay, so here we can define this kind of information, and then we'll have the same options here to define how the height or the slope will be introduced in the software. Okay, it's the same situation. Okay, once we define this part, we can accept it. Okay, and then we will create this span, this first span. Okay, we can duplicate these spans and use the same information again. Okay, if you want, and combine it. But we also, inside here, we have another option that I didn't show it before. That is the option. These were the predefined shapes, straight and curved. But we also have here the free shape. So the free shape, it's quite similar, but here we can create a list of flights and combine it here, and then have a resultant ramp. Let's say that. Let me show you one example. Here we can define, for example, the thickness or the depth of the slab, for example, 20 centimeters, and then I will add a first element here that could be, for example, I have here some numbers that I have been doing before. Let's create this first one as a straight flight. That's gonna be 3 meters long, with an elevation change of, let me see how I have 0.5 meters. Okay, and let's add some supports on the lateral left and right laterals of the ramp. For example, could be without a support, concrete wall, support on the lower or in the higher floor. For example, let me add some concrete wall in both sides. Okay, this is the width of the concrete wall. So I have this first piece of my ramp. Then I will do the same. I will duplicate this guy. So I have a second element here, the first and the second, and the second I will change it, and I will change it for a curve one. Okay, this is gonna be 90 degrees, and I will add here, for example, 2 meters, the inner radius. Okay, and I work with elevation of 0.95. Okay, 95, for example. And I will have the same situation. I will have here concrete wall, and I will have this situation. The first one that was a straight, I will duplicate it, okay? And we'll have the third one, okay? The first, then the third. But the third one, I will change, for example, the length. 3 meters maybe is too much. I'm just changing here some data just to show you how it works. I will change it to, for example, 1 meter, okay? And the elevation change is going to be very, it's almost flat, just 10 centimeters. Concrete wall, and I have this little piece here. This guy, I would like to create like a U here, to come from here and turn 180 degrees and come back, for example, okay? So this second element, I will duplicate again, and then I have an exact one here. And the first one, I will duplicate again, and I have that one, okay? And now I can see the result here. So I have a changing level of 3 meters, okay? If I delete one of them, I have 202.5, okay? So let's put it again, and I have 3 meters. And if we open one of them, exactly here we have a 0.5 meter. That is the difference between these two situations that I showed before, okay? So it's very easy to create this combination of flat slabs, or these combinations of flights, okay? You can also move the position of these flights here and combine it if you want, okay? So if you add one of them in one specific position and then would like to change it, there is no problem. You can use these blue arrows to change the list and create the geometry of your ramp here, okay? If I accept, the ramp is going to be here, and then I can accept it, and I have the ramp available to be introduced in my structure, okay? Of course, I must think before where the loads of this ramp will be located, because, for example, maybe I will need some supports somewhere, or a beam in the base of this, the points at which the ramp connects with the main structure, okay? We can, for example, I don't know, for example, I made one similar here, but I'll create a new one here. So for example, let's imagine I would like to put it here. And I can also now, once I define a first anchor point, let's say that, I can define the rotation of this ramp core, okay? If I use this button here, that is the orthogonality, I can have more precise introduction according just to the main angles, 0, 90, so the main angles, and then just click to confirm and introduce this ramp, okay? So it's quite easy to add a ramp. If we go to the 3D view, we can now see how it's represented in a 3D environment. Here I have those two ramps that I've been working before, okay? So we selected with wall in both sides. So here we can see the wall, and we can see that the geometry was introduced, well introduced here in our structure, okay? Something that we can do here with this element, we can open the ramps menu again. And as I said before, we can, for example, edit this information. Let's imagine that we want to change one of this data. We just open here and start working, changing the information that we want. Okay, no problem, very easy. So just open and edit whenever you need. That's using that button, it's very easy. We can also delete one of the ramp cores at any moment, or we can move this guy, okay, move in here for the place we want, or rotate this guy to the position that we want, okay? Nice. So actually, until this point, we're introducing the ramp. We were modeling the ramp, okay? So we can see that these five first options, they are used to model the ramp core. Then we have these other two buttons. I will start with this guy here before that is related to the forces and the displacements. So if I click here and then click in the core, we will have a ramp design. The ramp design will start, the software will start designing this ramp. So it's going to be very, very fast. Actually, we can have all the results in just some seconds, as you can see. And here we'll have some information related to the analysis. Okay, the interface here is quite similar to that interface that we have to the whole structure when we analyze all the other elements, like the beams, the slabs, the columns. It's quite the same system here. So here you can see the deformed shape, for example. We can add here, for example, a scale factor, like, I don't know, if I increase a lot here, I can see this displacement a little bit more. Okay, I can change the colors I'm using here in the scale, because actually the values that I have to the parameter or the results I'm selecting here, we can see the values in this bar here. So in this case, the deformed shape goes to 0.04 to 0.35 millimeters. So in the middle of the slabs, we have, as was expected, more displacements. But I can also change for contour plots like this. So yeah, it's quite nice to see like this. It's maybe a little bit easier to understand. And when we change to contour plots, we have different results that we can see here. For example, in this case, we are looking to the total displacement, but could be, for example, just the displacement in the z-x, for example, or just in the x direction, or the rotation in one of these specific axes. Okay, we can also select here and see the different forces, for example, the axial in different axes, or the moment in one specific axis, so for example in Y, or total shear, for example here. And there's one option that is quite interesting that is related to the checks. So here, when we design a ramp that require steel area due shear forces, we can see it here. In this case, in this ramp, I don't have any problem with that, so no reinforcements will be needed. But in case of my ramp needed, I could see here by the scale how much of steel rebars area would be needed to guarantee the safety of the structure, and then I should provide this reinforcements in the places where I see here in this kind of in this map, no, in this graph. Okay. Of course, all this data, it's for one specific load case, so could be the self weight, the dead load, or the live load. So I can work with these parameters to see how the results are, which is the behavior of the results of our analysis here. Okay. Coming back to the design option here, we also have this button. This button is to view the details of this ramp. The ramp was analyzed. So one of the main features of CYPECAD is to design, analyze, and provide all the results that are necessary to construct this structure. In the case of ramps, it's similar. It's the same situation. So first, here we have a table. This table with general data from this ramp, flight 1, the width, thickness, inner radius, angle, average slope. We have here the resume of the loads. So here we have the loads and also the materials that were used. Here we have the a plan view, so of the geometry of this slope, and here we have a detail of the rebars that are necessary to construct this ramp. As you can see here, that little piece that we've created, we can see here the difference. So this almost flat part of our ramp, probably that's not the best solution. Probably when we design a ramp, we should try to have the same slope in every pieces of this ramp. I confess that I was creating this model and this is not the best combination, but it's very useful to understand how it works. Okay, I think it's important to show you that here there are 3 sections, so it's why I've created this little piece here. And we can also see the sections here: section BB, FF, CC, EE, and D, and these sections are also represented here. So here we have BB, CC, DD, EE, FF, because AA, it's actually the section that is in this blue line coming from here, going until there, and is actually this guy here. Okay, so everything here is detailed. Of course, this information could be included in your drawings, could be exported in DWG, DXF, PDF. You can send it to your plotter, you can send it to an CAD software to keep working with that. Okay, here you can see how powerful is CYPECAD, because just adding this geometry, actually the software designed it, analyzed it, generated all the information, and we could also open the reports to analyze the checks of it.